Hello, everybody. We are excited to have you all here today for our tutorial on running online user studies with the reVISit framework. This is going to be a presentation and an active workshop tutorial presented by many different people. Our lead for this tutorial is Jack Wilburn, and then we also have Hilson Tresta, Zach Cutler, Yiran Ding, Brian Bowen, Carolina Nova, Elaine Harrison, and myself, Alexander Lex. So what is the plan for today? Well, let's talk a little bit first about what reVISit is. reVISit is an NSF-funded project that is now in its second year, and it's an open web framework for running user studies. It's really designed with the visualization community in mind. And so what we want you to be able to do with reVISit is to set up studies with all kinds of components, such as like consent and training and trials and tasks and surveys and so on. And also enable you to do sophisticated study design, for example, to proper randomization, Latin squares, and so on. We want you to be able to simply track your data and export the data that you collect with reVISit. We want you to be able to simply deploy and run your studies. And one of the big goals of this is also to make this whole thing fully reproducible and open. So the goal would be that you can share your whole study setup for anyone to rerun without having a license for software. For example, if you use the tool like Qualtrics, which also enables you to run studies, it's not as easy to share all of your material so that somebody else could rerun it and reproduce it. Now, a little bit about this tutorial. This format here will be partially theory, partially hands-on. So we will have a few lecture components, especially in the beginning, but then mostly it will be follow-along style. So we'll have the tutorial worksheet, and that has plenty of links in it. And we also bring up the links as we need them. And at the end of this tutorial, you will have created a simple study with reVISit that you can actually deploy and run and collect data with. I would also like to encourage you to sign up to the reVISit Slack team. Of course, for now, we'll be asking questions on the Discord, but we have a dedicated reVISit Slack. You can find the link to that in the worksheet as well. The benefit of using the reVISit Slack instead of the Discord is that, of course, we will be able to answer your questions after the fact and as you're going through building your own study. So this is kind of like our main point of support for anybody. And then, as any session at Viz, we have a Slido for questions, and we'll be monitoring the Slido. We'll try to make this as interactive as possible. If you're running into an issue, post it on Discord and post it on Slack. We have a large team. All of them are online today, and they will be able to jump in and help you. At the very end of the session, we'll do like a Q&A and a feedback session. We will use a separate Zoom for that will not be recorded, that will not be part of the live stream. So we'll send you the link at the end of the session. And then if you're interested, you can join that and have a brief discussion with us. So here's the schedule. I'm gonna not go through this in detail, but essentially we have lectures and activities. We'll start with this introduction here about what reVISit is, and then we'll go into setting up a reVISit study and building a simple study in the second half hour. Then we'll talk about components in the reVISit spec. Then we'll have a 10-minute break. We'll keep this a little bit shorter than by the schedule because we have quite a bit of content, and it would be kind of nice to have a little bit of time at the end. And then we'll do data analysis in reVISit, looking at some more advanced components, looking at advanced data tracking, looking at randomization strategies, deployment, how we recruit participants, how you can handle online data storage, and some future developments for reVISit. Okay, so now let's go through an example study so that you get a little bit of an idea of what a reVISit study looks like. So this here is a study that we ran and deployed. This is still live. This is now currently in kind of like study browser mode. So this is for example, if you wanted to debug the study, you could just jump around between any of the stimuli directly. If you were actually collecting the data, this wouldn't be available. This wouldn't be visible. And so you would have to go through those things. And so here's like a consent form. Here's like a little bit of a tutorial that includes animated GIFs. And then you have this random block here where you get different tasks where you have to do certain tasks with a data visualization and answer a question here and respond to that question in the form, right? And so if you click next, you jump to the next part. And so everything except for the main window here is reVISit, and the main window here is what you as the study designer develop and deploy. So this is what a typical study looks like. Of course, this is all fully configurable, and you can change this the way you like. So now, what are the advantages of reVISit compared to other study frameworks that are out there? First, it's designed for sophisticated studies. As I already said, it's designed for the visualization community in mind, and especially with building complex interactive stimuli in mind. But it also supports sophisticated randomizations, and it does very well with complex data tracking. So if you want to actually see what exactly your participants clicked and what they did exactly during the study, then reVISit is the choice for you. I already mentioned that it's reproducible and open. It's a non-commercial license that lets you share your study. Because it's open, it's also extensible, so you can add on features that you need. It is also currently in code and not a GUI. So like in Qualtrics, for example, you would assemble a study in a GUI, but our approach here is that you write a JSON description of your study. And that has the usual advantages and disadvantages, but of course, it's nice to version code, it's nice to share it, and so on. So these are all of the advantages of the code. And then you also get like one-on-one support from us. We really care about this project, and we want to make it successful. And so we're very dedicated in helping anybody who is trying to run a study with reVISit and help you be successful with this study. So that's what a typical reVISit project looks like. You have these 5 components. So at the first, in the first row here, we have the study specification and the components. These are the main things that you have to create to run the study. So the study specification is like where you, as the name already says, provide all of the information about the study, including like what the metadata, the UI config, and the sequence. The components are where your actual stimuli are, and I'll talk more about this later. And then you take those two together and you compile and deploy them on the web, or you can also do this locally on your browser, and you will have an interactive study web application like I just showed in this brief demo. Then you run your study, and behind the scenes, everything here is tracked. And the data is all stored either on local storage or in an online Firebase instance. And from there, you can either download your data as in a tidy format, or you can download full JSON that includes all of the provenance logs and so on. And the next step then is to do data analysis. reVISit is primarily designed so that you can do your data analysis in the tools of your choice so that you can work with downloaded data. But we have a few things that make it easy for you to like preview data that you're collecting, mostly to kind of like decide whether participants did a decent job and you should include them or whether you should reject them. So we'll get into all of these in a little bit and in much more detail later on. So let's talk about the components. The components are really where your study content goes. And we currently support 5 different types of components. The first one are markdown files. This is useful for introductions, consent form, help pages. These are like mostly static, right? But they can have form elements on them. And I kind of like the most easy thing to create. And then, of course, you can include images. This is like great for example, static visualization stimuli. Then you can include web pages. This is useful for custom stimuli. It's including interactive components where you use JavaScript. And then a little bit more sophisticated are React components. That kind of like has the advantage that it simplifies the communication between reVISit and the stimulus because React is stateful and we can track this more easily. And we'll talk about this in some more detail later. And then we have survey questions. These are kind of like illicit structured responses from participants. And so with these components, you can basically create any study that you can imagine and then compile them together into a reVISit study. And how you compile this together is specified in the reVISit specification. This defines the details of your experiment as a JSON file. And the spec has 4 components. The first one is study metadata. The second one is the UI configuration, like how it looks like. For example, the sidebar that you saw earlier is, of course, configurable. You can choose to not show that. Then you have the components and the base components, so where you define components, and base components are components that you can inherit from, making it a little bit easier and more efficient to write components. And then the sequence defines the order and the selection of tasks that participants see. So for example, you can randomize, or you can use a Latin square, or you can have a fixed order or anything like that. And all of these are defined in the spec. So this is like a simple example and like an incomplete example of what the spec looks like. But the idea here is like you see the schema at the top, then you have your study metadata where I cut out most of it. Then you have your UI configuration. Here is the main part where you have your components. And then at the bottom, you define your sequence. Every component has a response. This is like the primary way in which we collect data in a structured format to the components. So for example, here we have the component here is the first question set, which is a type questionnaire. And the response here is, like in this case, a text field where you can put in your first name. So that's what that would look like. And all of this information that is then put into this field are stored by reVISit automatically. And then for a sequence, this would be an example of a simple sequence definition, again, using the same definition for the demo I showed you earlier. So you start with a fixed order, you have an introduction, a consent, and a tutorial. Then you have a nested block here that has random order, and then it shows you in random order the different brushing conditions that we had in this particular study. And then we have a post-study survey, and then we have like a survey about reVISit in general in this particular instance here. So I want to spend a little bit of time on data collection because it's kind of super important. So the easiest thing we do is we collect data on the responses. We already covered this, but we also collect a variety of things about participants in sessions and logs. So for example, you automatically also get time information about responses. And we also calculate a clean time, which is kind of important. If you do studies online, you will have people that, pay attention for a minute, but then browse away. And we can detect that by listening to the browser. And so we report both the full time and the clean time. And then you also get participant metadata, such as browser information, locale, and so on. Then the most kind of like interesting part about reVISit studies is that you can, as I already mentioned, get full provenance data from your stimuli. So you can track data in your stimulus via our provenance tracking library, and I'll talk a little bit about later about this. And then you can also do think aloud tests and audio data, collect audio data with a soon to be released version, but I'll show a little bit of a preview of that. So that's something that will be in the official reVISit release within the next week or two. It's already working. Okay, so let's speak a little bit more about provenance data. So the idea is that you can instrument your interactive stimulus with provenance tracking. We built the track library a while ago that is kind of the best way to do this. And the provenance data that is then associated with each participant's session, each participant's trial, is stored as a JSON with the rest of the data. And that has kind of like two big advantages. A, it gives you new analysis possibilities. So for example, you can analyze interaction strategies. We've previously found that, for example, people were like extremely bimodal in their success on tasks. And when we looked at the provenance logs, we found that if they used strategy A, they were successful, but if they used the strategy B, they were not successful. And so that's really something that you can't do if you don't instrument your stimulus and log provenance data. But this is also important for reviewing individual user actions. So this is like, especially if you want to see where things go wrong, for example, during a pilot, or if you want to debug your study setup, this is great. And so here's an example of how this looks like. This actually also includes think aloud information, but basically what we see here is like a study as a participant completed it. And then I can hit play here. And now this here.
Okay, task. Consider only movies that had a production budget greater
Jump
than
ahead here. And now you can see the participants
perception.
interacting. This is not a video. This is a replay of the provenance log. And you can hear them speak at the same
halfway
time.
point here. So.
And so as you can imagine, this is super useful for you to find problems. And you down here, you see what are the events, like when did they click, so you can jump ahead and so on, and you can listen to the audio. We even automatically transcribe the audio for you. Okay, So another topic that we'll be covering today is data storage. reVISit is more or less serverless. So you don't have to run a server that has kind of like a lot of advantages in terms of simplicity and security and so on, and like long-term viability of having experiments up and reproducible. The downside is that, how do you store your data? And to do that, we'll have to use either local storage or Firebase. So local works out of the box. This is what we'll be mostly using today. And then you can download after you, for example, run a lab study with 20 participants. You can do this on one computer and then download from your local storage all of the data from your participants. Of course, this doesn't work for online user studies unless you want people to email you their files, but that's not a particularly viable option. Maybe for an expert study. But in most cases, you will have to set up a Google Firebase. And to be frank, Firebase is a little bit of a pain to set up, but we have good documentation to help you do that. And it's a reliable cloud storage option, which is also available with servers in many countries. So for example, if you have any restrictions that your data has to live in a particular region, you can achieve that with Firebase. And so we'll have a little bit of a teaser later in the tutorial on how to do this. And then we also have reVISit has different like study modes to kind of like account for the experiment lifecycle. I already mentioned that we have this kind of like study browser interface. So like if you're in study design and debugging mode, then you want to be able to jump around the study. You want to be able to see data. You want to see run through of your pilots. But if you're collecting participant data, none of that should be available, right? You should hide all of that, and you should hide all of the debug features. And of course, your participants also shouldn't get access to other people's data. And then eventually, after you've done your study and you've looked at your data, you might want to share your study publicly, for example, for a reviewer to understand what your study looked like. Or you might even want to share your data via the reVISit platform and via the analysis interfaces in there. And so you can kind of like configure that and directly set this up so that you have the right thing. I see there is a question for provenance data. Is there any tips on how to address the data storage in an IRB application? So I don't think that provenance data itself is a big deal. Like this is just log data, right? So that usually, you don't have to really mention that specifically. You would just say, hey, I'm logging interaction. It's a little trickier with audio data. You should definitely disclose that if you're recording people's audio. And you need to think a little bit about how you make sure that people's anonymity is preserved. But our IRB was fine with both in all of the cases that we've run so far, so we haven't really run into any issues. Okay, and the last thing that reVISit does is it has an analysis interface. Mostly this is kind of like your interface for downloading the data as a tidy CSV or as JSON, but it also lets you review and reject trials. So for example, if you have like a Latin square setup where you want exactly like a participant for every possible condition, then you might have somebody who is like did a bad job and you might want to reject them. And so this interface lets you do this. And it gives you also a summary preview of all of the trials that you've run. So this is kind of like your first line of looking at your data. And so with this, I wanted to hand over to Jack, and he will start our hands-on part. This was kind of like the introduction of all of the capabilities, and now we'll be diving deeper into those things. Thanks, everyone.
Thanks, Alex. Yeah, I appreciate it. So my name is Jack Wilburn. I'm with the University of Utah. I'm a senior software engineer on the reVISit project and basically the software architect for the reVISit project. All the decisions, good and bad, are mine. So if you have any problems, let me know about them. As Alex mentioned, we're going to be going over how to get started with reVISit. So there's a couple steps for getting started. And you're going to follow along with me. So let me share my screen here and we can get started. Okay, so you should all see my screen here. I have a terminal open and I have Safari open in the background. I'll be switching in and out of these. So we designed reVISit to work through GitHub almost entirely. So the first step for getting started with reVISit is to make sure that you have Git installed. It comes by default on any Linux operating system, but then on Mac, you can install it pretty easily. If you just type git status in the terminal. This will trigger the Mac OS installer for that. On Windows, it's going to be a little more tricky to set up, but I'm sure there's some good guides out there. Once you have Git set up, it's time to clone the repo. So what we're going to do is navigate to github.com. In the search bar, I'm going to search for our study, so our study repo. So that is reVISit studies/study. Once you search, you should see it as the first option here. And once you click on it, you'll be dropped into our page here. So we have some developer instructions here in the README that kind of go over how to set everything up. But since you're following along, you can just follow along with me. So the next step here is to fork the repo. So the first step, we're going to click this fork button over here. And what this does is it's going to copy the repo into your profile, or you can set it to go into one of your organizations if you're working with others. And this lets you work on a copy of the study that is completely separate, completely your own, but based on our code. So what I'm going to do is I'm going to fork the study to my repo here. It lets me know that study is available. The description is copied over from the repo, so I'm not going to touch that. Copy the main branch only is okay in this case. And then it says you're creating a fork in your personal account, and I'm just going to click create fork. This takes a couple seconds to copy all the information over. Okay, once the study repo has been forked into your repository, you should see it drops you into that repo itself. So here, I'm in my profile, and then I have the study repo. The next thing to do is to clone the repository. So under this code button at the top here, you can clone. If you have your SSH keys set up, you can use SSH, but otherwise, just copy the HTTPS link and you'll be able to pull your study here. For me, I'm just going to copy the SSH link. Now what you're going to do is change directory to wherever you'd like to clone the repository to. And then you're just going to type git clone. You're going to type git clone. And then you're going to paste in the link that was copied from the GitHub repository. So this will take a couple seconds as it's cloning all the assets that we have in the repository. Once it's cloned, you can CD into the repository here. So I'm CDing into study, and now you'll see that I'm in the project/study directory. In this directory, we have a few things. So here, if I ls, it's going to list out the directory. You can see that, for example, we have the source folder under src. There's the public folder, and we have some other files in here that are necessary to define our dependencies and to get everything working correctly. At this point, we're going to make sure that you have some of the dependencies installed that are necessary for this project. So the next dependency that we're going to need is Node. Node is used to run web applications. And since reVISit is a web application, we're going to need that. So to check if you have it installed, you can run node -- version. And for me, it's telling me it's version 20.14.0. Right now, there are multiple versions of Node out. You might have an older version. The minimum version required by the reVISit project is version 20. If you don't have version 20 or greater, you're going to need to go to your web browser. You'll go to nodejs.org, and you'll be able to just click this download button right here. So you'll see by default right now, it's downloading the 20.18.0. And yeah, if you don't have an up-to-date version, just click this, download it, follow the instructions, and then make sure that before you continue, you run Node version and you get a version that is 20 or greater. Once you have Node installed, you need to install Yarn. Yarn is the package manager that we're using on the reVISit project, and installs all of the JavaScript dependencies that we need. So to check if you have Yarn installed, you can do Yarn version. For me, it's telling me I'm on version 1.22.19. If you don't have Yarn or this doesn't work, you'll want to do npm i-g yarn. So this is npm install globally yarn. You can hit enter here, and this will install it globally. If this doesn't work for you, you get some error. On Mac and on Linux, you can override those errors quite often just by prepending sudo to the command, and this will run the command as a super user. So I already have yarn, so I'm not going to run this command, but if you don't, make sure you do. Okay, so now we should have all of the dependencies that we need locally, but we need to actually install the dependencies that reVISit requires to run the JavaScript dependencies. So the first step is to run yarn install for that. This will take some time to download all of our dependencies. You can see that it's pulling in things like Firebase and Track, which is our provenance library up here. Okay, so for me, that completed pretty quickly in about 10 seconds. It might take you a little bit longer. There's no worries. But now that we have the repository cloned and we've installed all the dependencies, it's time to open up the code in a text editor. I'm going to use VS Code for this. And then once you have the text editor open, we can run the server from there, and we can edit the files so that we can see what's happening. So I can do something like code period here, and that would open up VS Code. But I already have it open over here. So let me just pull that in. Okay, so inside the repository here in VS Code, we can run the server. So the first step to run the server is to do yarn serve. Once you run yarn serve, it'll tell you V is running. It was built in, for me, 160 milliseconds or so, and it tells me that the application is now live on localhost 8080. To verify that, I can open that link in the browser, and I'm greeted by the reVISit front page. So this front page exists on all deployments of reVISit, and in the development server, it is a list of your experiments that you have in here. So you can see there's quite a few. For now, the top 3 are our tutorial studies. And then below this, these are the studies that are on reVISit.dev. These are our example studies. So you can see these are demo HTML, demo Cleveland. These are our demo studies. For now, I want you to click on this first study here, tutorial-simple-study. And this will drop you into the study that we have set up. So this is the interface here, and we're going to work on this study to build it up. So back in VS Code, I'm going to navigate to the public folder. I'm then going to navigate to the tutorial folder, to simple study, and to the config. I'm going to clear out some of these. So the first thing, let's clear out the components here in the sequence. And let's clear out this components object right here. So you should have an empty configuration essentially. And let's walk through everything that's here. So in the schema, or in the JSON here, we define our schema. So this points to GitHub, and this is a JSON schema. The JSON schema gives us a bunch of cool stuff. So just for a quick example here, as I'm typing, I'm getting autocomplete. So these are things that we've defined as part of our schema that you can then interact with. And this helps with the autocomplete. And for example, this here, enumerate questions is a Boolean, but if I enter a number, I'm getting a slight underline here, and it's telling me incorrect type that it expected a Boolean. So you can use this for validation as we're going along. You don't need to modify this hardly at all unless you want to use a new version. So you can see we're pinned to version 1.0.5. But just by having this, we get all of these nice pieces, such as the autocomplete and the validation. The next piece is study metadata. In the study metadata, it's information about your study. This is shown on the landing page, so it makes it easier for you to develop. And of course, as you might share your study with reviewers or with a community, this is useful just so that they can understand who worked on the study and things like that. So in this case, we have a title. The title is a simple study for our tutorial. The version here is development. The authors are the reVISit team and the reVISit community. Now we have dates. Let's update this. So we're currently on 2024-10-13. We have a description, and this is just saying this is a simple study to demonstrate how to create a study using reVISit. And then organizations. So we have people here on our team from the University of Utah, Worcester Polytechnic Institute, University of Toronto, and then, of course, we're at IEEE Biz. After these two blocks, we have the UI configuration. In the UI config, we define a few things. So these are things that generally affect how the program looks as it's running. And it defines some things such as the help text path and the contact email. These are useful as you're running your study. If people need to get help, the contact email is shown in the interface and people can reach out to you. So I'm not going to belabor the point here, but there's a couple options that we have configured here to help with our study. Okay, so since we have this empty study where we have an empty components and we have an empty components in our sequence, if we go back here and we refresh, you'll see that we have no components on the right side. We're going to work together to build up this study here. Yeah, essentially that's it. So first of all, let's understand what assets we have available to us. So inside the public tutorial simple study assets folder, we have a few things. The first is a stimulus. So here, this is an image that represents some performance of AI models. We'll not get too much into this, but just understand that it's an image stimulus. We have a consent component here. So this is just a markdown file with some consent information. And we have a welcome markdown file, which just gives a brief welcome to the study. So you can see that assets-wise, we don't have a ton, but we can still build up a pretty complex study here. Okay, back to the configuration file, which is in tutorial simple study assets. I was like, not assets, tutorial simple study. And we're going to actually build up the components. So the components is an object here, and objects always take keys to values. So the key in this case is going to be the name of our component. So the first component that we'll work on is the welcome component. So I'll put the string welcome, colon, and then make another object using curly brackets. Components all have required properties. So you'll see here that right now it's telling me that I'm missing some properties. I'm missing a path, a response, and a type. There are multiple types of components, as Alex alluded to in reVISit, but this welcome component is a markdown component. So the first thing I'm going to type is type. To specify the type of the component. You'll see here that it's giving me some suggestions. So these are the possible component types. In this case, we have image, markdown, questionnaire, React component, or website. For us, the first one we're going to work on is a markdown. A markdown component requires a path. The path is the path to the markdown that you'd like to use. So in this case, that's all relative to the public folder. So from public, we want to go into tutorial, simple study, assets, and then we're going to go to welcome. So the path looks something like this: tutorial, simple study, assets, welcome.md. And then finally, every component requires a response. In this case, for the welcome component, we don't want to collect a response, so we'll just leave that empty. Now, if you were to save this and to refresh in the browser, you'll notice there's no change. Why is that? Well, every component that we have, if you want to see it in the sequence, we have to add it to the sequence. So down here, for me on line 37, I'm going to just add the string welcome, which is the key of the component in the object. With that, a save and a refresh will then let us render the welcome component. So you can see here, this is using Markdown to render things like headers and text. And we have a next button right here. Right now, clicking the next button just takes us to the end of the study, so it isn't super useful. To make it more useful, let's add some more components. Next component I'd like to add is that consent component that we talked about. This is another Markdown component, so it should look pretty similar. So I'm going to add the key consent here with another object. As before, it's going to require a type, a path, and a response. So let me type those out for you. So type is Markdown. Path is going to be a similar path as before. So I'll just copy this down. But instead of welcome, we're now going to be using this consent MD file right here. I'm going to update this to consent.md. And as always, we need a response. In this case, that will be empty. Now, for this consent component, I want to do a mild modification. So instead of the next button saying next, I would like it to say, I agree. It's really simple to do that. Just on the component, I'm going to look at the keys that I have here, and one of them is called next button text. We'll select that, and I'll say, I agree as the text. Again, I'm going to save, and if I go back to the browser and refresh, it's not there. If you remember, we have to add it down here to the components as well. So let's do that. Okay, so now that it's added to the components, if I save and refresh, we'll now see that we have the welcome component, where I click next, the consent component, where I click I agree, and then that will take me to the end of the study. One thing to note is we also have the study browser open right now, which is really helpful for while we're developing. This isn't always available, especially not to participants, right? We don't want them to be able to browse through the study as they're completing it. This is configurable through reVISit, but while you're developing, it's set to on. So this lets us navigate around. Okay, so we now have two Markdown components, but we're not collecting any responses. And we don't know anything about our stimulus that we mentioned before. The stimulus I'd like to show to participants and ask some questions. So to do that, I'm going to add another component. I'm going to add in our stimulus here. So I'm going to call this stimulus_1. And again, this will point to an object. The type of this component is going to be image. I'm going to give it a path to the image. Again, this is similar to what we had before. But instead of choosing these Markdown files, I'm going to choose ai-gender.webp. WebP being a image format. And you can see that this is under our assets folder here. The next thing I'd like to do is modify that next button again, but I'd like to just change where it shows up. I'd like to ask my questions in the sidebar here and have the stimulus in the middle so that the questions are separated from the stimulus. To do that, I can use the next button location key. And then we can see that we have three options: above stimulus, below stimulus, or sidebar. In this case, I'd like the sidebar. Now, to get some responses from our participants, we're going to have a response array. Inside here, we're going to ask a few questions. So I have an array with an object inside of it. Now, the objects have a few required keys. You can see here that if you hover, we're going to need an ID, a prompt, whether or not the answer is required, and then the type of the response. So let's address this. First thing is an ID. The ID that I'm going to choose for this one is going to be, I'm going to be asking about the AI and how it deals with women. The type of this is going to be a radio response. It's going to be required. So to set that, I'm going to say required is true. I'm going to ask a prompt. I'm going to ask for which profession did AI, typos included, generate women the least compared to US Census data. Fix up my typos, add some grammar, the question mark. And now there's only one more required property. So you'll notice that we actually have included the 4 required properties that it was initially asking for. However, because the JSON schema is pretty intelligent, it knows that we're using a type of radio for our question, and there's an additional missing property. Radio responses require the options property. So let's add that in. And in this case, we can just add them in as strings. So the options that I'd like to add here are going to be doctor, engineer, dishwasher, and janitor. There's one final thing that I'd like to add, and that is to move the question to the sidebar as well. To do that, I specify a location on this response object, and I'll leave that as sidebar. Okay, so that's quite a bit. But now we should have a component, stimulus1, of type image, using the image that we have in our folder over here. The next button location will be in the sidebar. We have a response here. We have an ID for that response. It's to type radio. It is required. It has a prompt. And it has these options for the radio. And we'd like that to be rendered in the sidebar as well. Here I can save, refresh, and we'll not see it. Again, that's because I haven't included it in my components down here in the sequence. So let's add that. Once it's added and saved, it's now a part of my study. I can navigate directly to it using the study browser. And this is what a participant would see. So since it's required, we can't click the next button yet, it's disabled. But as we click an answer here, the next button becomes available. And clicking next will record a response. Okay, this looks great for now. I'd actually like to add another question to this block. I'd like to know the same information, but for men. So to do that, the way I would go about this is I would copy this object, paste it directly below. And now we need to update it. So I'm going to change the ID to men. And instead of for which profession did the AI generate women the least, I'll change it to which profession did AI generate men the least. I can update my options here. For example, maybe I want to add another option. So maybe cashier is an option that we'd like to add. Since this is already included in our sequence, we don't need to update our sequence at all. It should just be a simple refresh. And then we have access to this additional question here. So you can see building with reVISit is pretty quick in terms of adding questions to components that already exist, modifying things like that. It's been pretty nice to work with. Okay, so now we have 2 markdown components. We have our image component, but maybe I just want to ask some questions of the participant without having a stimulus or a markdown. In that case, we can create a questionnaire component. So what I'm going to do is add another component down here. I'm going to call this one demographics. Again, it'll be key to object. And in this case, I'm going to call it demographics. And in my object, I'm going to require a few things. So as always, we need to specify the type. In this case, it's going to be a questionnaire component. So we'll specify that. We're going to need a response for a questionnaire component. And this is going to help us define our questions. So here, let's choose a few different types of responses just so we can see how they render. So the first thing that we're going to do is specify a response with ID, age. This response will be of type numerical. So we want to capture a numerical age for our participants. It's going to be required. And we need to add a prompt. In this case, I'll ask, what is your age? That's all we require for this one. I'm going to add another response here. This one I'll call ID color. This one will be of type. We'll do short text. I'm going to not require this one. I'll set required equals false. And my prompt is going to be, what is your favorite color? Let's add one more. Let's do a feedback. So here we'll do ID equals feedback. We'll have type. Let's have this one be a long text. Let's make this one required is also false. And let's set the prompt to, do you have any feedback regarding our study? Okay, this is a complete component at this point. In order to render it, of course, we need to add it to our sequence at the bottom here. Now that it's added and that we've saved, I can go back to the study and refresh. And you'll notice that we have this additional question here, demographics, additional component. And here we have our responses that we asked for. So in this case, what is your age as a numeric? So I can say for me, 27. And you can see that because this is the only required one, the next button is already available. If I was to delete my response from here, it becomes unavailable again. And modifying these at the bottom here doesn't affect it. It's only based on the required responses. So in this case, let's imagine somebody made a typo. So imagine it's me, and instead of 200 or 27, I put 270. In this case, this is probably not what the person had intended to do. It's possible to set some clamps on the numerical components here. So for example, we can specify a minimum age that we might require. In this case, let's have 0, and we can set a max of maybe 100. Now, if I was to refresh and try and typo that again at 270, as I move on, it clamps it down to 100. So the response is validated to be within those bounds. In this case, the participant would have to notice this and then modify it and say, oh, I typoed it. It's 27. We're looking to add a little bit more validation here, but for now, this is what we have. And then let's fill in these text ones. So for me, my favorite color is blue. Do I have any feedback? reVISit. It's pretty cool. Clicking next obviously submits that response. And you'll notice that as we go back, these responses are stored and are not possible to be modified. This is in case, for some reason, a participant is able to go back in the study, which we try to disable as much as possible. But even if they were able to, they wouldn't be able to modify their responses. Okay, with that, we've developed a simple study. We started with a pretty empty JSON file here, just with some boilerplate already filled out. We specified 4 different components, 2 markdown, 1 stimulus component, and 1 component to generate the demographics. and we filled out our sequence. So the order of the study was specified. Okay, with that, I'm going to turn over the time to Helston, and he's going to discuss some component types with you.
Hi, let me share my screen. Is the sharing okay?
It is.
Okay. Hi all, I'm Hilson Tresta and I'm a PhD student at WPI. So what we have covered so far are the examples of 3 different component types. We looked at Markdown, images, and some examples of survey question types. So Markdown is when we have like simple text that we want to show, for example, the consent form or the introduction. And we used images component when we have a static viz content. And similarly, we have survey component when we have a bunch of questionnaires like input text or drop-down inputs. But reVISit can do much more. For example, what if we want to create a complex visualizations where we have some user interactions with the visualization itself? So reVISit has more functionality to support these through additional component types, such as web pages and React components. So first, we'll take a look at the web pages. So web page can be a link to an actual website, which can be hosted, which might be hosted somewhere else, or it can be a path to an HTML file within the repository itself. And the HTML file can have its own JavaScript with libraries like D3, which can serve complex visualizations with interactions. So how it's going to work is that you define a component type as a website, and then in the path, you mention the path to the HTML file. So what happens is that whenever you have a path like this, the HTML file is then rendered inside an iframe, right? And now, what if we want to use the same HTML page with different data sets? You would normally have to make multiple copies of the same HTML file with different data set, right? So instead of that, with reVISit, we can have multiple stimuli pointing to the same HTML file, but with different data parameters. And so what you can do is that you can include the, so in the parameters, in the config, we can have the data that you want to show in the visualization. And in the HTML page itself, you can include the reVISit communicate.js script. And then what you can do is call the onDataReceive function, which is provided by reVISit. And this function basically takes a callback, which will give the data that has been set in the config. And using this data, you can visualize or use it in your visualization. And let's say that the participants interacted with the data, and now you want to store the response from the participant. So what you can do is, like in the config, you have the response block where you can take the response field. And so here we have to mention the type as iframe because this is all being rendered inside an iframe. And whenever you are done with the visualization and the user has interacted with it, you can call reVISit.postAnswers, and the response is then stored and sent back to the reVISit from the iframe. Okay, so that was web page, but with reVISit, you can also do the similar things with the React components, which simplifies the data, the passing of the data between reVISit. So if you have like a React component, you can basically get the props as the parameters and set answers function as a prompt. And what you can do now is that whatever parameters that you have set in the config can be received from the parameters prop. And after the user has interacted and you want to save those answers, you would basically just call set answer function, and which will store the data into reVISit. So those were the web pages and React components, and we also briefly looked at the survey questions. Survey question component is basically, it's composed of multiple types of input types. We have dropdown, numerical, Likert scale, short, long text, checkboxes, and radio buttons and sliders. So how it works is that in the config, we have to mention the type as questionnaire. And in the response field, it can be one of these different input types. So for the dropdown example, the type would be dropdown with a bunch of options with level and values. And similarly, the other input types also uses a similar pattern, like, for example, for a numerical one that you have already seen earlier, is that you had the type numerical, and you can set some threshold like max and min to validate the range of values that you can put in here. Similarly, for Likert scale, it's also the type. You mentioned the type as Likert, and you mentioned the number of items that you want to show with the right label and the left label, and which is displayed like this as shown here. And we have like other components, component types. Those are all listed in the source components response directory. You can check all of these components here. And for example, if you don't have the desired component type for these inputs, you can basically take one of these input components and create your own out of it and use it in the survey. So those are the different component types that we've used. I think that's all for session 1.
Yeah, we'll hand it over to Yuren, who will tell us a little bit about the analysis interface. Thank you.
Yeah. Thank you. I think Yuren will talk about the analysis.
Yeah, let me share my screen. Okay. Okay, hi everyone. My name is Yuren Ding from Mr. Polytechnic Institute. I'm a PhD candidate. So let's kick off this data analysis platform session for reVISit. So in the life cycle of an empirical study, so after building the experiment, the next step usually be the data collection, no matter it's a pilot study or the main study. Then the researchers usually have this preliminary data analysis stage. And then after we examine the data is all ready, then we'll dive into the analysis and the modeling phase. So reVISit provides this very convenient data analysis platform for preliminary data analysis. The features we provided is data download, participants data track, author distribution check, and time distribution check. So this, okay, so this will be like a demo and an activity session. So we have a session on the worksheet. There are steps that you can follow to explore the analytics interface. And I also will do follow these instructions and show those features myself. Okay, so the first step is actually start your reVISit in your favorite IDE. So yeah, simply use the yarn serve to start your IDE. Start use the reVISit. Then there are two ways to access the analytics interface. The first one is you can simply click this link in the worksheet, and you can access to the analytics interface. Or you can use this navigation section on the right side, go to the analysis. All right. So when you come to the analytics platform, the first page is a dashboard for every experiment you have. Let's take example of this one, the tutorial simple study experiment you just worked on. So here we have the number of participants in different status. So if so we have 3 status for the participants: completed, in progress, and rejected. As you can see in my database, there are 3 participants completed this study, no one in progress and no one rejected. And this is download data in the JSON file. So simply click it. You can check your data in the JSON format. And here we have the download all participants data in the tidy CSV format. So if you choose to download data in the tidy CSV format, you have the control of the columns of that CSV. For example, in this study, there's basically no instruction and descriptions. All these columns are empty, so you can remove these columns from your data, then click download. Okay. Then we have this accumulated participants count graph, which shows you the accumulated number of your participants. For example, in this study, I just put some data in this study yesterday. So you can see the participants number increased from 0 to 1 and 2. And today I have the 3rd try. So the data comes to 3 here. And we provide the time filter as well. You can manipulate the time filter to have the better visualization of the participants. Okay. Next, we will go to the table view of our analytics platform. So simply click this Analyze and Manage Study Data button. It will bring you to this table view of the data for the study. So in the table view, we have the details of the data for each participant in this study. For example, we have the metadata, which includes which browser the participant use and in which location this participants is taking this study. You can also check all the answers from each participant. Then we also keep tracking the time the participants are in each stage or in each trials. We have the total duration and the clean duration. The difference is if participants, when they're taking the experiment and they switch to another tab during the experiment, the clean duration count will pause. So as you can see, this one, these participants in the stimulus 1, it's the total completion time is 38.5 seconds, but the real time is actually just 9.8 seconds because this participant switched the tab during the when he or she is doing this trial. So okay, now let's say we think this data or this participants have some problem and we do not want the data from these participants. We can simply click on this checkbox and reject the participants. and give it a rejected reason. Let's say switch tabs. Then this participants will be in rejected status. As you can see, all the participants status count will be updated. And again, if you're trying to download the participants data in the CSV format, you will see some of them are rejected. I've already rejected some of them before, and you will see the rejected reason. And you can click on the download button again. Then the data will have the attributes of rejected status and the reason why it's being rejected. Okay, next we will go to this trial stats. So in this trial stats, basically we provided the time distribution for each participants in each trials. As you can see in welcome or consent trials, there will be no response. So we will only show the config file and the time distribution that participants are taking this trial. But on other stages, on other trials, we have responses. So apart from the time distribution, you can also check the answer distribution for each response. For example, this age response and height response. You can easily examine the data distribution at a glance. So for easy preliminary analysis and discover problems in the data. Okay, I think that's all for our data analytic interface walkthrough. So feel free to follow these instructions on the worksheet and explore all the features in our analytics interface.
Okay, thank you, Yiren. We're a little faster than we had planned for in person, where we would have had time to, help you with as you follow along. So what we'll do now is we'll go on break as scheduled for 1/4 and we'll stay on break until 1:45. So we will see you all again in roughly 38 minutes. So until then, thanks everybody.
Thank you.
Okay, welcome back everybody. I hope you had a good break. So we'll start with session 2 now. And session 2 will be getting into like a little bit more in the weeds, mostly on the technical front. We'll first talk about how we can create a React component. Then we'll talk about provenance tracking, randomization strategies, and how they're implemented. How we can session 2 now. Yes. Sorry, did I say session 1? Then we'll talk about how to deploy all of this, how to actually set up data storage, and then we'll do a little bit about our vision for reVISit, what we want to do next, and then we'll switch to like a feedback session where we would like to have a discussion with all of you in a separate Zoom room. Just a reminder that like everything that we're talking about today is actually based on our documentation. We put a lot of effort into our documentation. And so if you go to revisit.dev, you can find the documentation in the top bar. And there is like a tutorial entry for everything. So if you've missed some part, or if you want to kind of read up on it later, or if you prefer text over video, this is your resource that you could use. And with that, I'll hand it over to Yiren, who will tell us more about React components.
Okay. Okay. All right. Okay. Hi everyone. Let's kick off our session 2 with the advanced React component. So we have already seen the markdown stimuli type, images stimuli type in the previous introduction to the reVISit. But stimuli in data visualization study is not just images and text. They are interactive data visualization or applications. So and the response may not just always be ask you to type in text or multiple choices. We may ask participants to give the answer by interact with the stimuli. So sometimes we will need to use a React or vanilla JavaScript to develop our stimuli. Okay, here the reVISit framework will support the bidirectional communication between the framework and your customized component. Here is the example. This is called the click accuracy test. So this participants are asked to click on the moving circle, and the answer will be actually the click position, the distance between the click position and the center of the circle. So we will in this section we will like creating a similar but a simpler component to get practice. Okay, so in this activity we will learn how the reVISit framework can parsing parameters to your React component and how you can parsing the answer back to the reVISit framework from your React component. Okay. Okay, let's get started. So the instruction for this activity is actually inside your repo. So if you go to your start your dev server and go to the tutorial, advanced React component tutorial, you will see the instructions here. Okay, okay, so let's check the files we need to pay attention to. The first one is a config file. It's located in the public tutorial, advanced React component, and a config.json. So this is a config file that constructs this study. And the second file will be located in the src public tutorial, advanced React component, and it's called clickcircle.tsx, React, very simple React component. Okay, let's have a quick look of these two files. So in the config file, everything is pretty standard and very similar to the config file you see in the previous tutorial. The two things you will need to pay attention to is the response and the parameters attributes inside the click circle component. So the parameters is a place where we put our parameters that can be passed to this React component. And the response is a little bit different from the response type you've seen in previous tutorial. It's called iframe response type. So with this iframe response type, no matter your component is in React or it is in vanilla JavaScript, you can call in React. You can call the set answers function and passing the answers back to the reVISit framework. Okay, so let's check this click circle React component. It's a quite simple one. It's basically render an SVG and there's a circle inside this SVG. Let's take a look. So yeah, simply a circle, nothing else. And this function basically will capture your click on the SVG and get the coordinate of your click. And it will calculate the distance between your click and the circle center. All right, so from here, as you can see, the parameters controls the CX, CY, of this circle. So the coordinate now is 100 and 100. In the React component, we will pass the parameters as the props here, and we can decode every attribute inside these parameters here. So we have the CX and the CY from the config file. Okay, now you can try to change this to other numbers. For example, let's see, let's change it to 200 and 300. And you will see the circle position moves. So let's say if you want to have another trial, but with a different position, so it will be very easy to do. You can simply copy this component. So change this back to 100 and 100, and give it a new name. Change the response ID here and here. Yeah, and now you will have the click circle 2 trial. Then don't forget to add this click circle 2 to your sequence. Everything looks good. Then we can go back and start again. Refresh it. Now you will have two components here. One with position 100 and 100, and the other one with the new position 200 and 300. So it's very easy for you to create dozens or even hundreds trials with the same React component. And since reVISit grammar is very structured, so this component is actually very easy to generate by other scripts. Like if you can use JavaScript or Python to generate hundreds or even thousands trials with just change the parameters very easily. Okay, next we will take a look how can you pass in the answers back to the reVISit framework. So we have this iframe type response, and this set answer is a reserved function that in reVISit you will pass the props to your component. Then after you got your answers here, simply call this function set answers with your task ID, and the answers can be appended after this. So now if you click on the circle, your click distance to circle center will be 2 pixels, and this answer can be saved to the database. Okay. All right. We have another activity for you, is that can you maybe try to change this function? Then you can have another answers, a different one from the distance between the circle center and your click position. We can try a very simple example. Let's say now we don't want the distance. We want to see if we want to collect the data that if the participants click inside or outside of the circle. So we can have a new function called is within the circle. And if it's within the radius, we can give it a true or false, or maybe just a yes and no. Okay, and we can pass this answer using this set answer function. Okay, and you may notice right now the circle radius was set as 10 fixed. So if you want to change it, you can add a new parameter here. Let's say 10, and maybe for another trial, we can use another radius. say 20. Okay, and we also want to adjust the parameters here we used in the SVG circle here. We change it to R, and we also need to decode these parameters from here. Good. And yeah, let's check our result. Okay, I see. Yeah, the circle size has already been changed to 20. And if I click on it says click inside the circle, it will be yes. And on the next trial, if I click outside of the circle, it will be no. Pretty simple. So with manipulating the parameters and the response, you can add as much as make your React component highly customizable, so you don't have to recreate your component again and again. It's very convenient with reVISit. Okay. Okay, I think that's all for the React component tutorial. Now I will pass it to Zach to talk about the provenance tracking.
Great. Cool. Thank you. I'll go ahead and share. Okay, great. Let me make sure that works and looks good. Okay, so for the next 10 minutes or so, I'm going to talk about provenance tracking. So let me move my Zoom camera. So reVISit has two different types of provenance, which are actually very different from each other. So the first type is browser events. This consists of your typical mouse and keyboard events, such as mouse up, down, keystroke, etc. So primarily what would sometimes be called just simple logging, as well as a few extra events that the browser gives access to that I'll talk about in a second. The second type is application events, which are events which are specific to the interactions within your application. So this might be, brush events if you have a brush and a scatter plot, or filter events if your application has a filter. Really, the point is that this can be anything and is defined entirely by the programmer and the creator of the stimulus. So first, I want to give a quick rundown of what the browser events look like. So again, this is mostly mouse up, mouse down, key press events, as well as scroll events, focus events, kind of your standard browser events. One event I do want to highlight, because we use it in a few different ways, is the visibility event. So Yiren mentioned earlier that we calculate the clean time spent, and this is how we do that. So here's actually an example from a participant who took one of our studies. And what you see here is that the black box is them browsing away, which we can calculate by the visibility event. So what they did here was start our study, browsed away for a long time before coming back and actually completing our study. So this is useful to know, right? To not calculate this time in with the actual amount of time that it took for them to finish. And the cool thing about browser events in reVISit is that they really come completely for free. So we track and store all of these events by default. There's no additional effort required. The data is automatically put into the same tidy format that you would otherwise export your other data in, and can be analyzed by you however you want. So the other kind of event that we have is application events. And application events are a bit more dynamic, since they really depend on the type of interactions in your system. So we suggest using Track, a state-based provenance tracking library, which is developed and maintained by us. So I'm going to give an example of how to use Track with React, but we also have a bunch of examples on the reVISit site for implementing Track with basic JavaScript, for example. Track itself also has its own documentation. It has a separate plugin for Redux, sister library for visualizing stuff, and more of that. But today we're going to keep it pretty simple and not get into that complex stuff. So, but first, before I show you the code for application events, I want to kind of give a reminder of why we think application events are important. So, for example, here's a video very similar to what Alex showed you earlier of us rehydrating a provenance graph that we previously had. As you can see here, again, this is not a video. This is us just taking the provenance graph that we already have and then going step by step to watch essentially what the participant did. This rehydration is very, very useful in analysis and comes essentially for free if you implement track and the provenance tracking within your application. All right, so let me give a quick code example of how this looks. So I'm going to jump over to our brush plot. So this is the React component that creates the exact same component that we see in this video, which is a simple scatter plot with a brush and an accompanying bar chart. And we can see in here that we implement track. So track takes.
Can you zoom in a little bit?
Oh, yeah. Does that work?
Perfect.
Cool. Okay, so track really requires two things for you to initialize and run track. The first is to define a state. So as mentioned before, track is a state-based provenance tracking library, and this requires that you define a state for your application beforehand. So in this case, our state is this one line. All we're actually tracking is the state of the brush. So whether or not we have a brush, an x1, x2, y1, y2 for the location, and a list of IDs for our brushed elements. The other thing that track needs is some events, which can actually change this state, right? So in this case, our events are just the different things that you can do with a brush. So initially creating a brush is here, moving around a brush, resizing a brush, and clearing a brush. And one thing I do want to kind of stress, because I think this works really well, is that because this is already a React component, it already has its own state. So implementing track in that way is very simple, right? So as you can see, kind of all we're actually doing here is passing in the state that our component already has. So we don't have to do anything super fancy in these callbacks. So that's initializing track. And then from there, all you really need to do is actually apply actions. So as you can see on here in this move brush callback, we have a couple of different applies depending on what happened. And all this is a track.apply, and then using the actions that we already created, such as the brush move. And more or less that's it. Since we're already storing the state in our application, we just pass that state to track and it will keep track of it. And then the final thing that we need to do, since again, all of this at the moment is application specific, right? This is all being done in a stimulus that we created, which is kind of separate of reVISit. And now we need to actually tell reVISit to store our provenance graph. And the way we will do that is, as Jiren just talked a lot about, is to also use this set answer callback that gets passed to all React components. So that set answer can be used to set actual answers, but it also can be used to pass a provenance graph. So that's all we do, is that when we update the provenance graph, we call the set answer, pass our new provenance graph into it, and that's it. This provenance graph will get stored with your answers in the same spot as your answers, and also as the other mouse events, and can be exported in the tidy data format and also in the JSON. Okay, so let me go back. Great. So if there are no questions about that, then I'm going to continue on and talk about randomization. Let me get this set up. Okay, so randomization and really just, sequencing of the study components in general is, of course, crucial for any user study and something that we've really put a ton of effort into and iterated on a couple of times. So first, let's just get an idea of how sequencing works in a reVISit study. Actually, first, all the examples that I'm going to show here and edit from are in the public tutorial reacted randomization config.json. So feel free to follow along. After I talk about randomization, I am going to give a couple of quick tasks for people to try and complete near the end. So if you follow along, that would be awesome. Great. So also, I should mention, if you are running this study in this location, we should look like this. I should make it obvious where we're coming from. So if you have this localhost 8080, this tutorial or this interactive selection scatter plots will take you here and should look something like this to start. Great. Okay, so we've already seen from the setup that our sequence object controls the order of components which appear in the study, as well as just whether or not they appear in the study. And the simple example here is really fairly self-explanatory. So we only have one possible way of navigating through the study, and you will always see every component in this list. And importantly, you see this order fixed. Theoretically, you could just change this to order random if you wanted to randomize these. But that's really not what you want, right? You want to make sure that your introduction, consent, and tutorial come before your actual randomized, tasks, such as the paintbrush and the rectangle brush, etc. So really the critical part here is that we allow you to create nested blocks within this sequence, which is really what gives our sequence a lot of power. So here's what this might look like if we actually wanted to randomize the order of our tasks. So by creating an art block, which contains all of our actual tasks, and then setting that order to random, while maintaining the top level block order as fixed. So now, as we can see in our actual study, this is actually reflected in this sidebar. So we can see that the introduction consent tutorial will always appear first here. And then that our actual tasks within this are randomized. We can also click on next participant, just to show that this actually is random, and that every time you click next participant, this will change. Great. So now with an idea of how our sequence nesting works, let's talk about kind of the different actual randomization options that we have. We can already see really the two simple ones here. So fixed, which is self-explanatory, and random, which is important to note is truly purely random. Each participant will essentially just roll a dice, and this comes with no guarantees whatsoever. With extremely bad luck, all of your participants could theoretically get the exact same order. So the most common technique to get a better version of random is to use a Latin square, which is something that we have implemented. And first, I just kind of want to give a reminder of why a Latin square is so useful. I definitely expect that many people attending this tutorial already know what a Latin square is, but just a quick reminder. So let's say I want to have just 4 tasks, one of each of my brush types, a paintbrush, axis, slider, and rectangle brush. So here's an example of a possible Latin square, which can get created from those 4 tasks. Each row here is a different order, which a participant may see the tasks in, and they look randomized, which they are, but instead of being purely random, the Latin square actually comes with some guarantees. So first, you are, of course, guaranteed that each task appears only once. You're also guaranteed that each task appears in each possible position. So, for example, you can see that the paintbrush task appears in positions 1, 2, 3, and 4 for our 4 possible participants within this square. And this is true for all of the tasks. And additionally, another really cool thing about Latin squares is that they control for ordering effects. So, for example, in some studies, you might not want axis brush to come after paintbrush every time, right? That might result in some weird results because of, learning effects or whatever. So Latin square actually guarantees that each task immediately follows paintbrush is also different, right? So we see axis brush, slider brush, and rectangle brush comes after it. Great. Okay, so let's jump into the code. So when I go into my config.json, again, I am inside of this public tutorial reactor randomization config. And this is the config that is currently being demonstrated in our actual deployed version. So first, I can just change this to Latin square. Instead of order random, I just want it to be order Latin square. We can go back. Currently, this says random. If I hit refresh, now it says Latin square. Again, this won't result in anything looking particularly different. They will still look randomized. But what's happening behind the scenes here is a little bit important. So I'm going to talk about it. So what's really happening is that we are creating a series of squares. So, this is one square, but is only big enough for 4 participants. So we are creating many, many squares, kind of lining them up. And then as participants come in, we are removing, or not removing, we are assigning participants to individual sequences. So the first participant will get this sequence, the second participant will get the next sequence, and so on. And of course, you may iterate over many different squares depending on how big or small your study is. Okay, so right. So one more actually really powerful part of Latin squares that I want to talk about before we kind of get into actually setting up some more complex design for our study is this num samples. So within each individual block, another option that we have is this num samples, which I will set to 3 for him. And the num samples essentially tells this block that I only actually want to see the first however many, in this case 3, questions in this block. So for randomization, this can be really useful. So we'll go back to our study, kind of show what this looks like. We can now see that our Latin square is only 3 of 8, and that only the first 3 are actually available. The next 5 are grayed out. So participants will only see these first 3. And with a Latin square design, this actually works really well because of the guarantees that Latin square has. We can actually just cut this square off at 3. So if you pretended that these last 4 were all just removed, you still have the same guarantees that you had previously. So paintbrush will appear 3 times in the 3 possible positions, as will all of the other brushes. Great. So now let's talk about how we would make this study a bit more complicated. So currently it's just a 1-factor design, right? But let's pretend that there's some meaningful difference between these paintbrush Q1s and these paintbrush Q2s so that we can kind of make this into a 2-factor design. So let's say that we only want each participant to see either all of the 1s or all of the 2s. So to do that, let's copy this block and paste it. And then let's remove all the 2s from the first one and all of the 1s from the second. And let's also remove this num samples for now. So if we go back, and sorry, let me zoom in here. We can now see that we have these 2 separate Latin squares. One of the Latin squares contains all of our Q1s, and the other one all of our Q2s. Each of these blocks are still randomized in their own way, and it still have the same guarantees of a Latin square. But we didn't quite do what we want, right? Right now, we still are showing both blocks. So participants will see all of Q1 and then all of Q2. So instead, let's wrap all of this in a separate block. So let me, again, create a new block. remove my components and paste these two components into that. So again, this is really the powerful part, is this nesting structure really allows you to create these pretty complicated designs. And now within this, we only want to show one of these two components. So we will have our num samples 1. Now if we go back. Now we can see, in fact, we even saw that version we went to is gone, that we have our paintbrush Q1s all together. And that in this case, this is actually what's being shown. And our paintbrush Q2s are grayed out. So we can hit next participant, just to kind of show that this is random. The next participant will only see all of our Q2s, again, randomly, and whatnot. So this is now really a fully functional 2-factor design with the same guarantees that come with creating a Latin square, both for guaranteeing that participants see Q1 and 2 at similar rates, as well as guaranteeing that the randomization within Q1 and 2 are consistent. And really just a few lines of code. Okay, so next thing I want is, for anyone following along, I want to give you just a quick minute to kind of think about 2 different variations of this study that we're going to walk through, and then I'll go and actually implement these in a second. So the first one is to only see one of each task type, but randomize whether you see paintbrush 1 or paintbrush 2, or rectangle brush 1 and 2, etc. And the next one is to only see 2 of the 4 task types. So if instead of seeing all 4 task types, both questions, I just want to see paintbrush 1 and 2, as well as axis brush 1 and 2. Again, randomize within those. So I'm going to give people just a quick minute to think about this before I continue. Okay, so let's talk about these. The first version is that we want participants to only see 1 of each task type. So the way that we do that, actually just go back to our original here. That might be easier. Is to copy a few different versions of this. So we want to have, in the end, 4 of these. And then for each individual block, we're only going to have 1 task type. So we're going to remove everything except paintbrush, remove everything except rectangle, etc. Great. So immediately we can see how this works. Wait, hit a refresh. We're now randomizing all of the paintbrushes, rectangle brush, axis, and slider, but we're still seeing both. So what we need to do is set the num samples within these to just 1 instead of seeing both. I will copy this everywhere. And now we'll only see 1 at a time. And of course, one important thing is that we have now actually fixed the order of these, right? So we're randomly seeing 1 or 2s. So we can hit next participant to see that, well, those randoms are looking unrandom, but I promise you they are. That we are now randomly seeing 1 and 2s, but our order is actually fixed, right? So again, if we wanted the order to be random between like which one of these we see first, we would want to nest this whole thing in a separate block. Though I won't do that. I will just jump to the second version, which is have participants only complete 2 of our 4 task types. So this is actually pretty similar to what we already have. Let's get rid of our num samples 1 for all these. since we now want to see both. And now, again, we will want to nest all of this in a separate component. So let's go ahead and do that. And within this component, because we don't want to see all four, we only want to see two, we will just set our num samples to 2. And clean some stuff up. Great. So in just a few lines of code, literally took about 20 seconds, we have an entirely different study design where now we are just seeing the slider brush Q1 and 2, as well as the axis brush Q1 and 2. We hit next participant, this changes to axis and rectangle. And again, we have this kind of nested version of our randomization. So you both have guarantees of which questions are going to be shown, as well as the order in which they're going to be shown. Great. So I think that's all I wanted to talk about randomization. If there are no questions, the next thing we're going to talk about is actually recruiting participants. And I want to give a really quick demo of how this works within reVISit. So one thing I want to stress, because it's kind of important, is that reVISit is really a tool for creating these experiments, but we have no way of recruiting participants via reVISit, right? So what we frequently use as a team is Prolific, although of course there are other platforms, and integrating with those other platforms would be done very similarly to what I'm about to show you. So, but let's talk about what we do. Quickly, I'm going to jump over to Prolific, cheating a bit. Let's just hit a refresh here so I can show you what happens fresh. Is that when you go to actually create a study in Prolific, when you create a brand new fresh study in Prolific, it'll look something like this. We're going to skip most of the parts for now and really jump down to this data collection. And the critical part here is that we want to pass the URL for reVISit into Prolific. So this is the URL for our actual public version of this same study that I've been talking about. I'll go ahead and copy that and pass it into reVISit or into Prolific. And this other important part is this recording Prolific IDs, and we want to use URL parameters. So what this does is it will add URL parameters onto the end of our actual URL. And this is what people will see and what participants will click on when they go to take the study. And so within our individual config, so if we jump back to our config here, we take advantage of these parameters up in our UI settings. So within our UI config, we have two parts. The first one is our URL participant ID param, which essentially tells our application which parameters to pick up on and to use. So we want to use this Prolific PID. This is the default that Prolific gives, but you can set this to whatever you want. So, if you aren't using Prolific, you're using some other platform, you can set it to whatever that gives you. And then the other important thing here is this study end message. So this is the message that will always get shown at the end of the study when participants finish. And in this case, we want to give participants a link back to Prolific. So just an idea of what that link looks like. Each Prolific has a return link. So it has a code here. And essentially you just want to direct them back to that code. So now that I have this set up, I can click the previous participant, open study link in a new window to give an idea of what participants will actually look at when they start this. And now you can see that they opened our study, came to our actual study page, and importantly, we picked up on their Prolific PID, and we already inserted their Prolific PID here, and we don't let them change it. It's kind of important for making sure, people don't accidentally set their own names or whatever, and then we can keep track of participants between Prolific and our actual individual studies. And then we can also see that if we just jump to the end here, that we give a link to return back to Prolific, that if we click, Prolific says, great, you're done. And this is what participants see and how they know that they're done with this study. Okay, great. So I think that's all I had planned to talk about. I will hand it back over to Jack to talk about some more deployment stuff first.
Great, thanks, Zach. All right, so the next section that we have planned is deploying with GitHub Actions. So obviously deploying a study could be quite a daunting task. For example, in some scenarios, especially if you build your own study, you're on your own to set up a website, get everything live, make sure that it's working, make sure there are no bugs in the browser, things like that. However, with reVISit, it's something that we explicitly considered. So we built some nice scripts that help do the setup for you. It hosts using GitHub Pages. And yeah, basically when you fork the study, you get all this for free. So you'll notice that we have this .github folder in our forked repository. I'm in the forked version of the study here, the one that we worked on earlier. In this GitHub folder, there are some workflows. One of the workflows is deploy website. This here runs all the steps that are necessary to release the website. And it's able to be hosted straight away through GitHub Pages, so it's very seamless. When you fork a study, actions are disabled by default, and this is a security measure from GitHub. But if you trust the workflows that we've written, you're welcome to enable them here, saying, I understand, go ahead and enable workflows. Okay, and once workflows are enabled, in order to trigger the workflows, you just need to push a commit to main. So in this case, I'm in our repository here, and I'm going to be working in the terminal just to push a git commit. Oops. It's a little bit bigger for you. Okay, so we said git status, and we can see here that we're on our branch here. I'll do git remote-v as well. So you can see that this is set up to push to my version of the study repository. My next move here to create the commit, in this case, I'm just going to create an empty commit, which is not something that GitHub is set up super well to do. So I'm going to need to pass some command line flags. But if you follow along here, this is roughly how to do it with an empty commit. You could also make a change to a file and commit that. But for the empty commit, let's just do this. So I'm going to say git commit -- allow empty. And then I'm going to add a message. All commits need a message. And in this case, I'm just going to say push empty commits to enable workflows. It's going to do some linting based on what's pushed. It didn't find any files to lint in the change. So at this point, we now have this new commit that was added. To ensure that the commit is actually added, we can run git status. And this tells us your branch is ahead of the origin by 1 commit. So now I'm just going to git push. And that will have been pushed up. So you can see here, the latest commit is push empty commit to enable workflows. And in the actions tabs, our workflows are already running. You'll notice that 2 of them are running. One of them is lint and build. This just verifies that the code that you've pushed actually works. And there's this one here, deploy to GitHub Pages. What the deploy to GitHub Pages does is it will put in the repo, build it, and then deploy. So it does that by pushing to a GH Pages branch. So once this action says run, there'll be a new branch that's enabled. Now this might take a second, so let me just show you how this looks on our main repository here. So I'm going to just go back to the reVISit studies version of the repository. And let's look at an action here. So the latest one was this deploy to GitHub Pages down here for fix up configs. This workflow runs and does the deploy. And like I said, that will push the code to our GH Pages branch. So you'll notice this is the build assets from running yarn build. With this and some details in the pages settings here, which deploys from branches GitHub pages. Our website will be deployed to revisit.dev/study. And if we go here, this is the actual live version of our study, and this is an exact replication of what is available on our development branches. So this is a very easy way to publish your studies with very little setup. It uses all of the GitHub infrastructure to do it, so you don't have to host anything yourself. And yeah, we've run multiple studies this way successfully. Okay, the next thing that I wanted to talk about is data storage with Firebase. So switching gears a little bit here. Right now, everything that you've seen with the development version and in the development version that we just deployed, the data storage will be set up to run on local storage. So local storage is local to the browser, which means that if you were to run it with participants at this point, their data would be saved on their browser and would not be pushed up to some central place that you could see. In order to have a central place, we have integrated with Firebase. Firebase is a Google product. It has two different types of data storage. It has a real-time database for things that move quickly and are updating in real time. We use this for assigning out sequences to our participants. And then it has a storage or bucket technology, which allows for cold storage of data. And we use this for saving participant answers, saving their window events, saving their provenance graphs, things like that. One benefit to Firebase is that it can be hosted in many different countries, which can comply with ERBs and EU data privacy rules, since it's possible that your data doesn't have to leave your country. So why do we use it? We use it for data sovereignty. That means that researchers have access to their own data. The reVISit team doesn't have access to data. There's no walled gardens. You're completely in control. You can see the raw data. That is, you can go into Firebase itself and you can see how we've laid everything out. Although, of course, we expose that through the UI as well, so that you don't have to do that. It has built-in authentication and authorization, and it comes with some other features we've developed, like snapshots and backups. And of course, it works with our tidy data downloader and our JSON data downloader. Next, we're going to jump into authentication. So there's a couple things here. It requires that Firebase is configured. It enables admin users, privileged accounts to the analysis interface and the ability to change study settings, but it does not force your users or your participants to sign in. So I just wanted to show you where that is in the interface here. So again, I'm on the deployed version of the website here. This is the one that we just opened in the GitHub Actions. The settings for authentication exist in the settings tab right here. And inside of here, we have authentication enabled. It tells me these are the users that are allowed to access the website as admins. And of course, we have an interface here to add other people as well. In this mode, when we go to the analysis platform, admins will see all studies that are available, but it's possible to disable these studies for specific people who are not signed in. So there's a setting here, analysis interface publicly accessible. If I toggle this to off, everyone that is not an admin will not be able to see the study. Okay, and finally, Firebase enables another thing. It enables snapshotting. So this requires that Firebase is configured as well, and it enables snapshotting of data and full data management, including saving, restoring, downloading. And we've used it a lot to clear out our pilot data for studies so that we can just start with a fresh database for the actual study itself. And again, where does this live? So if we're on reVISit, we're going to make sure that we're in the analysis platform here by using this menu and navigating to analysis. Inside of here, you can click Analyze and Manage Study Data. In this case, we only have a couple participants. You can manage, go to Data Management. And here we have options to create a snapshot, archive data, and delete the live data. If we create a snapshot, you'll see that the snapshot gets created and we have actions down here. So we can do things like renaming the snapshot. We can restore this snapshot, we can delete the snapshot, And it's possible also to download directly from this interface here. So if we don't want to affect the database as it currently stands, but we want to download all of our pilot data, for example, you're welcome to click on these here and download just the database as it was stored. Okay, with these few features enabled by Firebase and the GitHub action script discussed, I'd like to hand it over to Lane to discuss what's coming next for reVISit.
All right, does that show okay?
Yep.
All right, thanks so much. Well, everyone, I think reVisit's been a very exciting project, really to see how quickly people can get up and running with a demo study. So again, I think there's definitely room to grow and some things that our team is very excited about, some things that are on our roadmap. One are our studies and open examples. We recognize the need for open science for replication studies in key areas that will help the onboarding process for a tool like reVISit, so people can actually use it to address their pain points. So we're planning some studies, replication studies across health and across kind of perceptual psych and interactive visualization. So be on the lookout for those. We have some folks that are collaborating with us in the broader community. So folks who are reaching out for supports to run studies of their own. That's very exciting. We love to help. So that's something to look forward to, is building the community. And some specific features, just because now that we have built a base, we keep thinking about, okay, what are the features that will make it next level? So one thing is this idea of audio data and think aloud studies. Traditionally in crowdsourced settings, we like to run studies that are sort of a person interacting with a visualization or kind of perceptual style studies. But I think with modern browser technology, we can explore other options. And one thing that we're looking at in particular, and that's coming live very soon, are Think Loud studies, where you can turn on a participant's microphone with permission, of course, and auto transcribe as they go throughout the study. What's very cool is that the domain-specific language for reVISit sets up sort of a natural breakpoint that you can auto kind of correlate with the audio transcript. So I think that's very exciting. It's going to produce something that if you've ever done it manually, you know what a pain it is. So that's a killer feature that we're working on. Another is component libraries. If you run studies in your lab, you know that you're often going to develop your own, for instance, Likert scales, or you're going to use the same NASA TLX over and over and over again. In this case, we want to make that possible for reVISit by building out a component library explicitly that has some common things that you might want to do, things like attention checks, but also some modern tools from the visualization community, things like the visualization literacy assessment test, things that others might want to use. Another idea is data hosting. So, it can be a little bit of a barrier to set up your own Firebase. We want to explore some options for default data hosting, where we can sort of kickstart you, so that you can get something running and collect some data, while then you can, kind of, if your institution requires you to store your own data, you can get that set up. Also looking for, connections to other database options. That's something we're going to post to the community. If there is a need there, we want to be responsive to that. UI configuration, same thing. What if you don't want to code your own domain-specific language for your reVISit config, but you want to actually do this in a drag and drop way? Actually, by building a language foundation, it becomes possible to build things like a UI on top of it. That's something that we want to look at. Finally, we have an improved analytics interface. So if you've ever run a study, you might have had the same experience that we had, where we're like, it would be cool to see this running live and to kind of analyze the data and think about it as it comes in. So we're looking at new features for the analytics interface as we run more and more studies, things like identifying outlying participants. So I don't want to call them problems, but like, maybe we haven't structured our experiment well enough to engage everyone. So we can identify when that happens and kind of hone into how things need to change or identify, low effort participants more easily and sort of, kind of complete that analysis loop when we're designing an experiment. But with that, I will hand it over to Alex to talk about community.
I think Carolina will do that.
Carolina.
Yes, thank you. Thank you, Lane.
Would you like to share?
Well, it's just one more slide. So if you want to just change the slide over, that'd be great. Yes, thanks, Lane.
Yeah.
Great. Well, thank you all for being here. We're very excited about this project. And obviously, one of the big things that makes reVISit work is getting you guys to join in the community and actually use the platform. So the first step here is to join our Slack. So if you look at the notes for today's tutorial, the tutorial worksheet, you will see an invite link for Slack, and that's where we're on there all the time. So we'll have all the tech support there and everything like that. We're also really excited about setting up meetings either virtually with people who want to set up, as well as going and traveling to your institution and running something similar to what we've done today, but in person, to run a tutorial with your students, with your lab, to kind of really help to get reVISit off the ground with different institutions. So definitely reach out to us and we can kind of get you onboarded. So for the last session, for the last part of today's session, we want to do a kind of, let's hear about your pain points, what works, what doesn't work, and things like that, really get your feedback. But in order to do that, we're going to move over to a separate Zoom room in the interest of, we don't have the video consent formed for everyone if we were to do it here where it's streamed. So we're going to go off to a non-recorded kind of more intimate setting, if you will. So that's the link right there. We have Alex's Zoom link and we will move over there. Alex, any last points we should mention before?
No, please join us on that Zoom. We'll drop off here and be up there in just like a minute.
Yes.
Thank you,
Hopefully
everybody.
see you all there.